Now let us look at question 2 in that same mock examination 2025. So the question is a question on quadratic equation again and combination. And the question reads, P and Q are root of the quadratic equation 9x squared minus 4kx is equal to negative 1 plus 6x, where k is a constant. Show that an equation whose roots are 1 over p and 1 over q is x squared minus 4k minus 6 multiplied by x plus 9 is equal to 0. And the second question is a question on combination. We are going to read that later and solve. So for that question, the first thing to do is that you need to understand and rewrite this equation into the standard form of a quadratic equation. And we know that the standard form of any quadratic equation is in the form ax squared plus bx plus c equals to 0. So I need to transform this equation into a standard form. So how do I do that? First, I need to send all the terms to the left-hand side. And if I send all the terms to the left-hand side, then I will be having 9x squared minus 4kx. This term, which is negative when I send it to the left-hand side, all becomes positive. That's why I have plus 1 plus 6x equals to 0. But in the standard form of a quadratic equation, I should have one term in x squared, which is this. Then I should have one term in x, so I have to factor out x from these two terms. When I factor out x, now I'll be having negative 4k as the term in this x, and I'll be having positive 6 as the term in this other term, the coefficient. Then all that I factor it out, so I multiply by x, then plus 1 equals to 0. Now it is in a standard form because here the value of a is 9, the value of b is all of this expression, negative 4k plus 6, and the value of c is 1. So I have a as 9, b as negative 4k plus 6, and c as 1. Now the next thing to do is that we were told that the roots of this equation, are p and q. So I'll go ahead and I'll find the sum of the roots and the product of the root. So the sum of the root becomes p plus q, which is equals to, and is given by negative b divided by a. So I'll be having negative, and b is all of this expression, then divided by a, and a is 9. So when I distribute the negative into the bracket, I'll have 4k minus 6 divided by 9. So this is the sum of the root p and q. What about the product of the root? The product means I multiply the root, so p times q, which is pq, and is given by c divided by e. C is 1, and of course a is 9, so I have 1 over 9 as the product of the root. Now in order to form any new equation, we have to use this equation, x squared minus the sum of the new root plus the product of the new root is equals to 0. So I need to find the sum of the new root. We were asked to form a new quadratic equation whose new roots are 1 over p and 1 over q. So I'll return here and I'll find the sum of the new root, which is the sum of 1 over p and 1 over q, and the product of 1 over p and 1 over q. Then if I find them, I substitute it into this formula. Then I should have the proof. All right, let's go ahead. The sum of the new roots are 1 over p plus 1 over q. Finding the LCM, I have p times q, and doing the division, I have p times q divided by p is q times 1 is q. P times q divided by q is p times 1 is p. So I have q plus p or p plus q, as addition is commutative. So I can come back to this root since the roots were symmetrical, and I will see that the sum of the root p plus q was this expression 4k minus 6 divided by 9, and the product of the root pq was 1 over 9. So I'll be having 4k minus 6 over 9 divided by 1 over 9. I'll reciprocate and the 9 cancels out, and the sum of the new root is 4k minus 6. Doing likewise with the product of the new root, I multiply them. So when I multiply, 1 times 1 gives 1, p times q gives pq. So, and pq is the product of the root, which is 1 over 9. So I'm saying 1 divided by 1 over 9, that reciprocates the 9 and then gives me a value of 9. Now I have the sum of the new root and the product of the new root. The last thing I'm left to do is just to plug them into this equation, and so I'll have x squared minus the sum of the new root, which is 4k minus 6 multiplied by x plus the product of the new root, which is 9, is equal to 0 as required. I hope you've understood how we solve this, but if you do have any questions, please do not hesitate. Just drop it in the comment section and I'm going to come in and answer your question. All right, let's return back to the presentation. Okay, now the second part of the question is a question on combination. In a box of 12 fuses, 4 fuses are chosen at random and inspected. So we have 12 fuses in that box. And with the 12 fuses, 4 fuses are chosen from that box at random and they are inspected. And we have been told that the box is rejected if more than one fuse is found to be faulty. Very, very important. The box is rejected if more than one fuse is found to be faulty. That means the box will be accepted if one or no fuse is found to be faulty. And we have been told again that there are 3 faulty fuses in that box. All right, let's get the fact here straight. So the box contains 12 fuses and we want to select 4 fuses from that box. And then there are 3 faulty fuses. That means the fuses that are not faulty, that are good, will be 12 minus 3, which is 9. And they say, in how many ways can the box be accepted? So the box can be accepted if no fuse is faulty or one fuse is faulty, because the box is rejected if more than one fuse is faulty. All right, let us put that into writing. So the total fuses in the box, 12. The fuses to be selected, 4. And if there were no restrictions, then I will do that in 12 combination 4 ways, because selection, or when you are choosing something, then you can do that using combination. So if no restrictions were given, then the 4 fuses can be selected in 12 combination 4 ways. Then let us go ahead. Then the faulty fuses were 3. That means the good fuses would just be 9 minus 3, would just be 12 minus 3, which is 9. Now, what are the ways in which the box can be accepted? The box can be accepted if no fuse is faulty, or that means I'm going to add it since the event now will be mutually exclusive, or one fuse is faulty. Now I'm going to find a number of ways in which I can choose 4 fuses in which no one of them is faulty, and a number of ways in which I can choose 4 fuses where one is faulty, and I will add their result. Now let me go on. No faulty fuse can be selected in. I'm going to take the box, and out of those 9 good fuses, I will select 4 fuses from those good fuses. So it can be selected in 9 combination 4 ways. And punching this on your calculators, that will give you 126 ways. Then in how many ways can one faulty fuse be selected? In this case, I'm going to be selecting 3 good fuses out of 9 and 1 faulty fuses out of 3. So I can do that in 9 combination 3 ways, and I can select 1 faulty fuse in 3 combination 1 way. And if I do the maths, I'm going to have 252 ways, and I'm going to add up these values. So the total number of ways of accepting a box will be 126 plus 252. That gives me 378 ways. All right, I hope we have come to the end of question 2. But again, if you find this video useful, don't forget to drop a like, subscribe to the channel if you haven't already, and turn on the bell icon to receive notifications each time I post new videos. Thank you for your kind attention, and see you later.